Hi, this video will talk about how to solve rational equations. So the first thing we want to do is get our variable out of the denominator. And the way we're going to do that is the same way we've done this throughout algebra. Get rid of our denominator. The way we get rid of our denominators is multiplying through by our least common multiple. So first I'm going to look at the numbers. Here I have a 1 in front of my x, so I don't need to worry about that. I've got a 3 and a 6. What is the smallest number that both 3 and 6 go into? And that is going to be 6. Okay? And now I want to look at my variables. I have an x, 6x. And so now what I want to do with that is multiply every single term by 6x. The first term, the second term, and the third term. I cannot leave one of these out. I got to make sure I do everything. Okay, so when I multiply each term, notice what happens. My denominators will go away. Notice I have an x in the numerator, x in the denominator. They cancel out to give me 1, and now I'm left with 6 times 1, which is 6. Okay? Over here, I have a 3 in the denominator, so that goes to 1, and I have a 6, so the 6 is going to go to 2, because 3 goes into 6 2 times. So what am I left with here? A 2, an x, and a 2. 2 times 2 is 4, so I can simplify that into 4x. And last, I've got a 6 in the denominator, a 6 in the numerator. They cancel out or go to 1, and I'm left with 5x. So I'm going to have minus 5x. All right. Notice that my denominators have all gone away, and now I'm just left with something that is pretty simple to solve. On the right-hand side, I'm just going to combine my like terms. 4x minus 5x just gives me a negative x. And I have that that's equal to 6. In order to get rid of my negative, I can think about this as dividing by a negative 1 or multiplying by a negative 1, whatever's easier for you. Negative 1 over negative 1 would go to positive 1, leave me an x, and 6 divided by negative 1 will give me negative 6. Now let's do the same thing over here. I only have one denominator over here, and that is an x. So in order to get rid of it, all right, in the denominator, or bring it out of the denominator, I'm going to multiply every single term by the LCM, which in this case is just x. Okay? So every term is going to get multiplied by x, right? Multiply x here, multiply by x here, and multiply by x here. Now I forgot something important over here. Whenever we're solving rational equations, we have to worry about if we plug our x back in, we cannot get a 0 in the denominator. So we need to always check that. So notice if I plug negative 6 back in, I'd have gotten minus 1 6. So no 0 in the denominator, we're fine. But we want to make sure we keep that in mind. Okay, over here, in my first term, the x's cancel and leave me the 10. Over here, I get x times x, so that's going to give me x squared. And then in the right-hand side, I get 3 times x, so that's going to leave me 3x. And now notice that I have a quadratic, or in other words, an x squared term. So I'm going to have to solve this using what I know about quadratics. Whenever I solve a quadratic, I want to make sure I get everything equal to 0. So I'm just going to move the 10 and the negative x squared to the right-hand side. So I get 0 is going to be equal to x squared, because to move this over, I'd add x squared each side, plus 3x. That doesn't move, so it's going to stay the same, and then minus 10. Because in order to move the positive 10 over, I would subtract 10 each side. And now the way I solve quadratics, first get them equal to 0, and then next I factor. So I'm going to factor this right here. I'm looking for two numbers when multiplied together give me negative 10, added together give me a positive 3. So x plus 5, x minus 2. Again, 5 times negative 2 yields negative 10. 5x minus 2x would yield a positive 3x. So in this case, I'm going to have two solutions, x equal negative 5 and x equals 2. Once again, I need to go back to the original problem and make sure that if I plug these values in, they don't give me a negative number. Give me a 0 in the denominator. Okay, that's what my watch out is, 0 in the denominator. If I plugged in negative 5, I would get a negative 2 right here. That's okay. And if I plugged in positive 2, I would get a positive 5. So neither one of those give me a 0 in the denominator, so I'm fine. They're both solutions. And you can plug those in and prove to yourself that they both will make this a true mathematical statement.